Welcome and study with Tanzania Institute of Education.
Hello, my student. My name is Revocatus Joseph Mbuga. I'm a chemistry teacher. Today, we are going to discuss about organic chemistry. Organic chemistry have many different subtopics. Today, let we discuss subtopics known as aromatic hydrocarbon. Welcome. We are going to discuss these subtopics of aromatic hydrocarbon through guiding questions. Question number 1, A, Roman 1. Convert benzene into benzene carboxylic acid. The symbol which represents benzene molecule is this one. We are supposed to convert into benzene carboxylic acid molecule. In order to convert benzene molecule into benzene carboxylic acid molecule, use or remember to use chemical reaction of benzene or chemical properties of benzene. For example, benzene molecule converted into benzene carboxylic acid, there is addition of carboxyl group. So let me discuss how to add this carboxyl group into benzene molecule. First, let me try to convert benzene through addition of only one carbon. So reaction which can be used here is alkylation of benzene on a presence of iron 3 chloride. So methyl chloride treated with benzene molecule on a presence of iron 3 chloride catalyst. Result, addition of methyl group on a benzene ring. Addition of methyl group on a benzene ring result addition of only one carbon, which is required to form carboxyl group having only one carbon. So to convert benzene having methyl group to benzene having carboxyl group, use a chemical properties of benzene which is known as oxidation of benzene. The oxidation of benzene molecule having methyl group by using strong oxidizing agent on a presence of sulfuric acid cause oxidation of methyl group through removal of hydrogen and attachment of two oxygen atoms, which bring formation of a carboxyl group, and the molecule of benzene become benzene carboxylic acid. So two steps here are used, and by considering our question does not limit which step are required to be used. So here, through conversion, two steps are used to convert benzene molecule into benzene carboxylic acid molecule. For this step number 2, strong oxidizing agent used is potassium permanganate. But there are 3 strong oxidizing agents. For example, potassium permanganate, potassium dichromate, hydrogen peroxide. But for this step, tried to use strong oxidizing agent potassium permanganate. But another student will be able to use potassium dichromate, but not hydrogen peroxide, because hydrogen peroxide is not as strong as potassium permanganate and the potassium dichromate. Roman 2, convert benzene into benzene propanone. Since this question does not limit us How many steps are required? Here we are able to use only one step. How to convert benzene molecule into benzene propanone. So you are supposed to consider how many carbon atoms are added to a benzene ring. The propanone added to a benzene ring have 1, 2, 3 carbon. So we are supposed to use acyl compound, which having 3 carbon atoms. This is acyl compound having 3 carbon atoms treated with benzene on a presence of catalyst known as aluminum chloride or Lewis acid. And this reaction, remember student, is known as acylation reaction, a chemical properties of benzene. So when benzene is treated with acyl chloride, having 3 carbon atoms, that formation of benzene having attached propanone. Roman 3, convert ethane into benzene methanamide. So ethane have 2 carbon, but benzene methanamide have cyclic chain of benzene ring and methanamide. So by using a knowledge of chemical properties or chemical reaction of different organic compounds, let us discuss how to convert ethane, which is aliphatic, carbon-carbon open, into benzene methanamide. Step number 1, let us consider, student, how to prepare benzene from aliphatic hydrocarbon. Here, aliphatic hydrocarbon have 2 carbon atoms. So in order to convert into benzene methanamide, remember one preparation of benzene, which involve formation of alkyne having 2 carbon atoms, known as ethane. So we are supposed to convert ethane into ethane. Then ethane can be used to produce a benzene ring. For example, here ethane treated with chlorine on a presence of UV light, which results in formation of chloroethane. Chloroethane should be converted into double bond. Once treated with conc, sodium hydroxide, elimination reaction takes place at alpha and beta carbon, which results in formation of double bond. That double bond compound is known as ethene. So remember to convert double bond into triple bond. In order to convert double bond into triple, or in order to prepare alkyne compound from alkane, consider 2 chemical reactions applied to produce triple bond from double bond. There is preparation of triple bond from vinyl compound, and there is preparation of triple bond alkyne from diols. So let we consider this ethane to be converted into vinyl compound. Or another student can able to use another mechanism to convert double bond ethene into diols. So let we consider conversion of ethene into vinyl compound. In order to convert double bond into vinyl compound, remember chemical properties of alkane. When alkane or double bond treated with halogen on a presence of carbon tetrahalide at very low temperature, it results double bond split and allow addition of halogen, which is that formation of vinyl compound. Then vinyl compound can be converted into triple bond or alkyne. Reagent which are required to convert vinyl compound into alkyne: sodium hydroxide and sodium amide. Concentrated sodium hydroxide and amide alkaline solution, is that reaction to take place at alpha and beta carbon. Hydrogen and the chlorine at both beta and alpha carbon become eliminated, which results formation of ethane. So ethane can be applied to produce benzene. Through polymerization of triple bond known as ethane, having 2 carbon atoms, the ethane polymerize, which become benzene at very, very, very high pressure and high temperature. Then formation of benzene ring can be applied to form benzene methane amide. In order to convert ethane to benzene, consider method for preparation of benzene known as trimerization of ethane. So a molecule of ethane can be trimerized or polymerized into benzene under the following condition which is required: high pressure, and high temperature in a system. The high pressure and the high temperature bring trimerization of molecule of ethane, which form molecule of benzene. Then in order to convert benzene into benzene methane amide, what we consider chemical properties of benzene. A methane amide attached to benzene ring, it has 1 carbon and a amino group. So let us start with addition of 1 carbon to benzene ring. Through alkylation, benzene treated with methyl chloride on a presence of Lewis acid, example iron chloride or aluminum chloride, did that formation of methyl benzene having 1 carbon. Through oxidation, methyl which attached to benzene become oxidized by strong oxidizing agent, potassium permanganate, on a presence of acidified or sulfuric acid. Another oxidizing agent which can be used here is potassium dichromate on a presence of sulfuric acid or acidified potassium dichromate. The methyl become oxidized, which is a formation of benzoic acid. So benzoic acid having carboxylic group can be converted into alkane amide, which having 1 carbon known as methane amide. So remember chemical properties of carboxylic acid. When carboxylic acid treated with phosphorus pentachloride or phosphorus trichloride or thionide chloride and followed by addition of ammonia, the carboxylic group become amide. And if it become amide, the amide should have only 1 carbon known as methane amide. Then these are almost steps which applied to convert ethane into benzene having methane amide. Several steps applied, and no problem, because this question asked does not limit step which are required to be used. But there is another question, student, you'll be asked to use a certain step which are required. So you are supposed to shorten other step in order to have appropriate step asked. Question number 1B. Arrange the following compounds in order of increasing basic strengths. Give reasons for your choice. The organic compound given, most of them are aromatic amine. So the basis of aromatic amine depends stability and availability of lone pair of nitrogen of amino group. So according to compound of aromatic amine given, there is difference in basicity. It depends how that chemical compound occur. For example, for first one is less basic than this one. The reason behind, the lone pair of nitrogen of amino group are not stable and discovered are not available. Why? The lone pair of nitrogen of amino group undergo mesomeric effect. The lone pair donated to benzene ring by positive mesomerism become unavailable and become more difficult for these aromatic amine to donate lone pair to the coming acidic substance. So these are aromatic amine which is less basic than this one. For this second aromatic amine have methyl group attached on a benzene. So why this is more basic than this one? The amino group have nitrogen which have lone pair. That lone pair undergo methymerism, but the benzene ring which withdraw lone pair from this nitrogen of amino group have methyl group. That methyl group release electron to benzene by positive inductive effect. So the tendency of methyl group to release electron to benzene ring by positive inductive effect stabilize the lone pair of nitrogen of amino group, which result these have higher ability of donating lone pair than these aromatic amine. So the second aromatic amine is more basic than the first one. The third one is more basic than the first one, the second one. The reason behind, the lone pair of this amino group released to the benzene ring, and if released to the benzene ring by mesomeric effect, there is another group here attached to this group. This releases electron to nitrogen by positive inductive effect, stabilize the lone pair of this nitrogen, and they make this lone pair to be available. So why this is more basic than this? For this third aromatic, the methyl group attached direct to nitrogen. But here, the methyl are not attached direct to nitrogen, attached to benzene ring. So stabilize lone pair in less extent, but this one stabilize the lone pair of nitrogen in larger extent. Contribute the third aromatic amine is more basic than second one. The last one is most basic aromatic. Why? The lone pair of nitrogen of amino group are very stable and more available. Why? Does not undergo mesomeric effect. So since are very stable and available, these the last aromatic amine have an ability or have higher ability of donating lone pair than all other given aromatic amine, and the result to be most basic than all given aromatic amine. So in order to determine, for sometimes to be given aliphatic, these are aromatic. When you be given aliphatic, for aliphatic you are supposed to consider the kind of amine, type of amine, primary, secondary, tertiary, and you are supposed to consider the number of carbon atom attached to amino group. But for aromatic, you are supposed to consider attachment of amino group, how attached to the benzene ring. So here, all given amine are aromatic and have different basicity. Question number 1C. Write down the UPAC name of the following organic compounds. Roman 1. For this organic compound given in Roman 1, we are supposed to use principle or rules which applied to assign UPAC name of aromatic compound. So for this, there is two substituent group. So here, more dominant or group which have high preference is carboxyl. So if this group is of more preference, so carbon number 1 should be this carbon which have more dominant or group of high preference. So position, we are supposed to start at this point, carbon number 1, 2, 3, 4. Or carbon number 1, 3, carbon number 1, 2, 3, 4. So amine or cut carbon number 4 from this group which have high preference. So the UPAC name of this compound will be 4-amine benzene, and these have only one carbon, methanoic acid. Or 4-amine benzoic acid. Benzoic acid. But according to the UPAC system of naming, you are supposed to name by using the first one rather than the second one. This is a common name, not UPAC name. So we are supposed to name by using 4-amine benzene methanoic acid. For question Roman 2, benzene ring attached to nitrogen, and the nitrogen having alkyl group, 2 alkyl group. So here we are supposed to use a principal Lulus which used to provide the UPAC name of amine instead of benzene, because these group are not among those group of preference applied to name a benzene molecule and their derivatives. So you are supposed to use the principal or Lulus of amine organic compounds. So by using principle of naming amine, nitrogen have 2 alkyl group and a phenyl group. So we are supposed to name these attached to nitrogen alphabetically. This group is known as propyl, this alkyl group is known as ethyl, and this one is known as phenyl. So alphabetically, let us start with N, ethyl. Then there is propyl and there is phenyl. So N, phenyl, then N, propyl, followed by name amine. N, ethyl alphabetically, N, phenyl, and N, propyl amine. So the principle of naming benzene here are not applied. You are supposed to use principle which applied to name amine organic compound, because the substituent group attached to benzene are not found in a group of given substituent group of benzene considered to have a required principle of naming. For Roman 3, benzene ring attached to only one substituent group. So this substituent group are not found in a series of substituent group applied to name benzene. So here we are supposed to use the principle of naming amine. And the benzene should be branch group attached to this carbon, and the amine having how many carbon? 1, 2. The position of branch group attached to amine, you are supposed to consider the first carbon which attached to amino group. So the first carbon is this one. Second carbon is this one. So amine here have 2 carbon atoms. So the position of phenide will be 1 phenide, longest chain 1, 2 amine. So 2 carbon is ethane amine. 1 phenide ethane amine. For Roman 4, there is benzene ring and 1 substituent group. This substituent group are found in all substituent group of naming benzene. And this is a keto group. And if the keto group, this group or this substituent group attached to benzene ring is derived from organic compound known as ketone. So on the naming should be benzene have how many carbon atom? 2. So from ketone should be ethanone. Ethanone. Benzene ethanone. And the last one, there is 2 benzene ring and the substituent group attached to both benzene ring. These groups are not found in all substituent group of naming benzene. So here we are supposed to use the principle of naming alkene and not principle of naming benzene. So here alkene have how many carbon atom? 1, 2, 3. 2 benzene ring should be substitute to be branch group attached on the alkene compound. So the first one attaching on the first carbon and the second on the second carbon. So the best position here will be 1, 2 and the not 2, 3. So here will be 1, 2, phenide, phenide should be diphenide. Longest chain 1, 2, 3. Double bond attached on the first carbon, so propene 1. 1, 2 diphenide, propene 1. Question C, Roman 1. Benzene ring have 2 substituent group. One is carboxylic, another is amino. To provide the UPAC name, let me consider which among these 2 groups is more dominant or group of high preference. Carboxylic group is a group of high preference, so the first carbon should be this one. And you are supposed to use a direction which be at the smallest position. For example, 1, 2, 3, 4, amino occurred carbon number 4. By using another direction, 1, 2, 3, 4, amino occurred 4 carbon. So the UPAC name of this should be 4 amino benzene methanoic acid. So amino is a substituent group of low preference, should be written before naming benzene, and the carboxylic is a substituent group of high preference, should be written after naming benzene. Roman 4, benzene ring have 1 substituent group having keto group or keto carbon. So this substituent group have 2 carbon atoms. So this is a group of high preference, and this should be a branch group attached to ketone. So on naming benzene as a branch should be named as phenide. Have 2 carbon, ethanone. Phenyl ethanone. Let us end up here for today. We shall proceed in the next period. But before we close our lesson, I would like to leave you with some questions.
Let's study, be educated, elimu kazi. Elimu kazi. Let's study, be educated.